Hi everyone, today we're looking at Module 2, Lessons 5 and 6, the definition of rotations and properties, and rotating 180 degrees. We've looked at a couple different transformations so far, translating figures and also reflecting. So today we're focusing on rotating. So let's write our title, Module 2, Lesson 5, the definition of rotation and properties. So the basic properties of a rotation are the same as the basic properties for translation and for reflection. So we've gone over these three properties several times. I'm writing them down again just so that I don't forget. The first is the mapping property. Mapping means moving an object from one location to the other. And when we map an object using a translation, a reflection, or a rotation, we map lines to lines, rays to rays, segments to segments, and angles to angles. Our second property preserves length or distance. And our third property preserves the distance of an angle measure. So I didn't write that down, but I would like you to. We're talking about distance of an angle. When performing a rotation, we have two important things that we need to keep track of. The first is a center, and the center of the rotation is usually marked as a 0. And the second is the distance of our rotation, and we usually write that as the letter D for the degrees that we're going to rotate. So for example, if I have this little triangle and I want to rotate it around my center O, I would rotate it a certain number of degrees, which is D. In this case, I'm making my degrees 270, and it would show that rotation. A rotation of 90 degrees is always 1/4 of a turn. So if you have a transparency paper and you want to rotate 90 degrees, you just want to turn it 1/4 of the way around and you'll get that nice 90-degree rotation. We typically rotate in increments of 90 degrees. So first we rotate 90, 180, 270, and then 360. We can also rotate in a negative direction, 90 degrees, negative 180, negative 270, and negative 360. D, that degrees, is always between negative 360 degrees and positive 360 degrees. If I go in a negative direction, I'm going clockwise or to the right, and my positive direction goes counterclockwise or to the left. That's going to help me determine which direction I'm going to when there is a rotation. And whenever I rotate an object around a center, it's going to preserve that distance. So the distance from the object to the center is the same as the distance from the object to the center in its new location. Now we're going to look at Module 2, Lesson 6, and this is specifically about rotations of 180 degrees. Rotations of 180 degrees are special because they have some really interesting properties. A rotation of 180 degrees creates a straight line and causes P to be collinear with O and P prime. So take a chance to write that down. If I have a point P, and I want to rotate it around O, my center, 180 degrees, I'm going to get P prime, the same distance from O as P is from O. And in 180 degrees, it brings me to the same kind of line that P and O exist on. So those points are collinear. That means they share a line. Since angle measures are preserved, a 180-degree rotation of an angle creates a really interesting type of angle, which is called a vertical angle. And those are going to be equivalent all the time. So I'll show you a little example of what that looks like in a second. Another interesting thing about 180-degree rotations is that on a coordinate plane where my center O is equal to the origin, the point 0, 0, when P is point AB, P prime is the opposite of A and the opposite of B. So this may look like negative signs, but right now they're actually standing for a notation which is the opposite. And I'll show you another example of that. So that's all for today. Make sure to get all your notes complete and finish the left-hand side of your page. And don't forget to pause, rewind, and play.